In the dormitory, making a glittering electromagnetic rail by hand is simple. Everyone has seen this year's Zhuhai Air Show, right? This domestically produced electromagnetic box, which already participated in the expo in the year 22, became a hot topic. And its principle is electromagnetic coil acceleration. Its application field is very wide, even including electromagnetic catapults for carrier-based aircraft. Install 1, 2, 3, 4 female magnets on the frame. The 2 magnets in the front are N-pole facing each other, while the 2 in the back are reversed to become S-pole to S-pole. At this point, we place a copper coil on the track. If we apply a current to it, it will be acted upon by the repulsive force of the front magnet and the attractive force of the rear magnet, thus being propelled out. Connect the power and try it out. Oh, the speed is quite fast. Install positive and negative electrode patches on both sides of the rail, connecting 2 metal contacts. When the 4 patches touch each other, the circuit will connect, thereby launching the slide block. Flies quite fast. The effect looks pretty good, but actually this trigger system is not perfect. Larger gaps can affect electrical coupling, so we need to replace it with more effective silver brushes. Installing the brushes directly on metal patches. Very good. The working state is very stable. Next, increase the number of magnets to give the slider more thrust. To continuously supply power to the slider, the bracket is modified to have 2 layers. Magnets are installed on the top, and metal guide sheets are installed on the bottom. Positive and negative electrodes are alternately connected to make the circuit regularly connect and disconnect. Provide continuous power output to the slider through 4 boost points. Simplifying the slider's size and reducing weight can also increase speed. To reduce costs, this can be priced lower.
Reluctant.
After the modifications are complete, quickly test the results. Not bad, not bad. The slider shot out quickly, but some residue was left on the starting contact point. It looks like melted copper wire adhered to it. Also in slow motion, the slider's movement was poor. The repulsion from the first magnet twisted the slider, causing the brushes to lose connection and producing a lot of electrical sparks. So further modification is needed here. This time we choose to use cured resin as a material that doesn't easily deform to reprint the magnet bracket. The transparent material is both strong and attractive. A piece of iron secures the copper brush, welding the power source in a C shape on the contact bracket. The base piece is bent and fits perfectly on top. Once it gets burnt, it is also easy to replace later. Drill holes at equal intervals along the track, mainly for threading power wires, to make it easier to distinguish between the alternating positive and negative poles. Insert a copper strip on each side of the side brackets, welding the positive power supply to one side and the negative power supply to the other. At this point, you just need to connect the bus to the copper strips. Flying so fast it looks even better with the lights off. Next, we will continue to add magnets and contacts all at once, up to 80. To be honest, there are quite a lot of small parts, making it really labor-intensive to assemble. The brackets are installed side by side on the track, connecting each positive and negative contact point, with alternating magnetic poles of the magnets fixed. Be careful not to get it wrong. Next is the triggering device. We can't always use a clip, so use a 3D printer to make a spring holder with flexible hinge connection, installing the trigger and return spring. Let's see how it works. It looks pretty good to the naked eye, but in slow motion, you can see that there's a recoil the moment the switch makes contact. Does it have any impact? Yes, it causes the first 2 magnets to not provide enough thrust to the slider. However, changing several materials did not solve the problem. Based on the principle of the dry yellow pipe magnetic switch, we finally designed this magnetic attraction combination solution. In slow motion, the bouncing phenomenon nearly disappears, perfectly meeting the standard. The protective brackets were installed on the bipolar contacts of the track, and our electromagnetic track is completed. Hurry and try a paper airplane. It's so fast it zooms out with sparks and lightning. It can provide such power without needing ignition or high power current. It's truly user-friendly.
Do you want to try it without waiting for it to burst immediately?
Replay before death shows he was very peaceful. The immense impact flung the slider away. Another starch sausage, it was too bouncy. Using flexibility to overcome rigidity, a small force deflects 1,000 pounds, directly dissolving this wave of attack, splitting the slider in 2. Attach a sharp tip to the small car, instantly transforming it into a bullet train. Little grape can die. Alright, it shattered into pieces. Time for cornstarch tea. Wow, there's always something that overcomes another. Chang escaped disaster once again. Next, let's rub 4 sliders with different numbers to see which one runs the fastest. Can't see it with the naked eye. Let's add a marker to make it easier to distinguish. With a high-definition camera and software calculations, even when tested with 16, 32, and 48 volts, the slider with 200 turns was always the first to cross the finish line. In theory, the more turns, the greater the electromagnetic force, and the speed should also be faster, right? However, there is a weight issue here. Too much copper wire also adds a lot of weight. Although the 400 ampere slider achieves the higher speed, it ultimately fails due to the weight problem. Let's test the track thrust with pliers. Well, it flew quite far. Finally, we present the ultimate test project. A 138-gram foam airplane. Print a special launch carriage and quickly test fly it. Not bad at all. On the first test flight, it perfectly crashed the cup holder, but the plane's takeoff posture was quite nice. Calculating the plane's exit speed is approximately 10 meters per second, which converts to about 37 kilometers per hour. It's not that fast. Of course, we can also switch the positions of the coil and the magnet, which also results in strong thrust. For example, the electromagnetic guns at air shows. What do you think of these big beauties? Do you love them?